AP Chemistry. This is Lesson 9, the last lesson of the Foundations unit, and it's on naming compounds. So ionic compounds consist of a cation, that's the metal, that comes from the left side of the periodic table, and an anion, that's a nonmetal. That would be like oxygen, nitrogen, fluorine, chlorine. When naming an ionic compound, the cation is named first and retains its original name. The anion is named last, and the end of the anion's name is changed to IDE, I. So here are some examples. The metal is sodium, the nonmetal is chlorine, so sodium is going to pass an electron to chlorine. The cation will then be the sodium, and that it retains that name. It has a positive charge, and then the chlorine has an extra electron, so it becomes a chloride ion. So the compound is called NaCl, or sodium chloride. So the first name, sodium, stays the same. The chlorine changes at the end of its name to IDE, chloride. Potassium, fluorine. Potassium is the cation. It passes the electron over to fluorine, and then that becomes a fluoride ion. So its Kf is the chemical formula, and it's called potassium fluoride. Magnesium and oxygen. The magnesium passes an electron over to oxygen, actually two of them, and that becomes an oxide. So you have MgO, and that's magnesium oxide. Lithium and sulfur. Lithium retains its name. The nonmetal sulfur becomes sulfide. It becomes an anion. So it's Li2S. You need two lithiums at +1 to match up with the sulfide at 2-. And so that's lithium sulfide. Some transition metals have more than one charge state, and you can find that on your charge numbers by ion sheet or on your 60 common ions. For example, iron Fe can be ionized to a 2+ or 3+ charge, meaning that the atom either loses 2 or 3 electrons. Which one it is not something you need to concern yourself with. Just understand that it can take on more than one charge. When naming an ion with more than one charge state, a Roman numeral is used in the name. So I is 1, II is 2, III is 3, IV is 4, and V is 5. So the way Roman numerals work is if you put a smaller Roman numeral in front of a bigger one, like IV, it becomes 5 minus 1, so that becomes 4. Iron can form two different compounds with oxygen. So let's look at those. You have iron and oxygen. Now, if it's iron 2, if it's the one that becomes a 2+ charge, then it's going to match up directly with an oxygen, which is a 2- charge. So that would be iron 2 oxide, and it's FeO. Again, the iron here has a 2+, the oxygen has a 2-. They perfectly balance each other. So that becomes iron 2 oxide because it required an iron 2. Now, what if it was an iron 3? Can that match up with oxygen? Yes, it can. Iron, oxygen. Now you have iron 3, so it's a 3+ charge. But oxygen can only have one charge, and that's a 2-. So you have a 3+ and a 2-. So what you have to have is 2 irons. That's 2 times 3+ gives you 6+, and 3 oxygen. That's 3 times 2- gives you 6-. So you end up with 6+, 6-. Let me say that again. The irons are +3, so 2 of them is +3 times 2 is +6. The oxygens are 2-. You have 3 of those. So 3 times 2- is 6-. So you end up having a 6+ and a 6-. They balance out. That's what an ionic bond needs to do. So you have iron 3 oxide. Here's some more examples. Copper and fluorine. Copper can have two different charges. One of them is copper 2. It can take on a 2+ charge. Fluorine can only take on a 1- charge, so you're going to need 2 fluorines to balance the copper. So it's Cu F2 and that's copper 2 fluoride. Titanium, chlorine. So we're going to have titanium 4. That's one of the charges that titanium can take on. The chlorine has a 1- charge, so you're going to need 4 of them. 4 of the 1- minuses to match up with the 4+ of titanium. So it's TiCl4, and that's going to be titanium 4 chloride. Cobalt, bromine. Cobalt has 2 different charges. One of them is cobalt 2, so it's a 2+ charge. It's given up 2 electrons. The bromine has a 1- charge, so you need 2 bromines to match up with a cobalt 2, so it's COBr2. So that's cobalt 2 bromide. There is an alternative nomenclature. Nomenclature means naming system for transition metals with 2 main charges. The lower charge number uses the suffix -us. The higher charge number uses the suffix -ic. Now I'm going to tell you these are kind of old-fashioned. You won't see these names much, but you could come across them. So let's just go over them here. So FeO is iron 2 oxide, or it can be called ferrous oxide because iron can have a 2+ or a 3+. So 2+ is the lower number, so that becomes US, O-U-S. So ferrous oxide. So iron 2 is replaced by the word ferrous. Now you have Fe2O3. As we just saw, that's going to be an iron 3 oxide. So that's going to be ferric oxide because 3 is the higher number. You have 2, you have 3, 3 is the higher number. It takes the IC suffix there. Copper 2 oxide. So copper 1 is the lower of the 2 charges. So that can be called cuprous oxide. That's the same as copper 1 oxide. Or you could have CuO, so that's copper is going to be copper 2. That's the higher of the 2 numbers, 1 and 2. 2 is the higher of the 2, so that's going to become cupric oxide. Lead chloride. So this is lead 4 chloride. We're going to say it's lead 4. So that's going to be the higher of the 2 numbers for lead. Again, you get that off your charge number by ion or your 60 common ion sheet. So lead doesn't go by lead, it goes by plumbus or plumbic. So 4 is the higher of the 2 numbers that it could take, so that's going to be plumbic chloride. If it's PbS, that's going to be lead 2 sulfide, so 2 is lower than 4, so it's going to take the OUS, so that's plumbus sulfide. Sn is tin. So this is tin 2 oxide. Tin can either be 1 or 2. So that's the higher of the 2. That's the lower of the 2. Tin can either be 2 or 4. So that's going to be stannous oxide because 2 is the lower of the possible charges. Or you can SnF4. So that's tin 4. That's the higher of the 2. So that can be IC. That can be stannic fluoride right there. Finally, mercury. So mercury 1 oxide, that's the lower of the 2. So that can be mercurous oxide. Or this one, HGS, is mercury 2 sulfide. So that can be mercuric sulfide. Okay, you're pretty much never going to come across these, but part of knowing naming, you should know these. Now naming covalent compounds. So covalent compounds use prefixes, that is words that are attached to the front of a word to indicate the number of atoms. So the prefixes, you may have heard these in other places, are for 1, it's mono. For 2, it's di. Sometimes 2 is bi, bi, but in this case it's di, di. 3 is tri. 4 is tetra. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. And 10 is deca. So the rules for naming covalent bonds are the least electronegative atom, which is usually the central atom, is listed first. Use the proper prefix in front of the element. The exception, don't place mono in front of the first element name. So you'll see examples of that. 3, add the suffix after the word "ide" to the end of the last atom. And note, unlike ionic bonds, which consist of 2 atoms and are charge balanced, covalent bonds can consist of many atoms and they can produce ions. Let's go through some examples. H2O, we call that water, right? But what would that be in terms of the naming convention that we just talked about? There's 2 hydrogens, so it's dihydrogen, and there's 1 oxygen, so it's monoxide. So take the O off mono when you apply it to oxide, so you don't say monooxide, it's monoxide. So dihydrogen monoxide is the formal name for water. CO2, carbon dioxide, because there's 2 oxygens, not monocarbon. You don't put the mono in front of the first element, so it's just carbon dioxide. SO3 is sulfur trioxide, so you don't put the mono in front of sulfur, not monosulfur, but you do put the tri for 3 in front of the oxygen or oxide, so it's sulfur trioxide. N2O4, now you have something other than a 1 in that first element, so that's going to be dinitrogen tetroxide. Tetra means 4, dinitrogen tetroxide. Take the A off the word tetra when applied to oxide, so it's not tetraoxide, it's tetroxide. CCl4 is carbon tetrachloride, 4 chlorides. And IF7 is iodine heptafluoride. Hepta is 7, so iodine heptafluoride. Okay, now there are what are called molecular ions. These are covalent bonds, but they form an ion. They have a charge to them. And we'll talk about why that is at a later time, but here's the naming for those. So if it has a 1- charge, here are the ones that do, of the ones we're going to talk about here. Bromate is BrO3-. Iodate is IO3-. So those are covalent bonds because they're between nonmetals. So those are 2 strong guys, so they form covalent bonds, but they do end up with an extra charge there, an extra negative charge. Nitrate is NO3-. Chlorate is ClO3-. The next column is going to be 2 charges. They're going to have 2 extra electrons. That's sulfate, SO4 2-, and carbonate, CO3 2-. And finally, there's one that has a 3- charge. That means 3 extra electrons, and that's phosphate. That's PO4 3-. You should memorize these, okay? Memorize these 7, not only their formula, but how many charges they have. So the way I remember it is BINC SCP. However you remember that, that's kind of a mnemonic. So bromate, iodate, nitrate, chlorate, and then SC is sulfate carbonate, and then the P is by itself is phosphate. So carbonate. So here's how you name these 8s. First of all, you memorize the 8. We just did that. So that's CO3 2-. Memorize the 8 ions. Now we're going to learn what happens if there's a different number of oxygens. So we're going to add and subtract some oxygens from CO3 2-. It does not change the charge. It's still going to be a 2- charge for carbonate. So let's go up here. So now we added an oxygen. We have CO4 2-. What do you do with the name? You add the prefix per. So it's 1 more oxygen than 8, and you add the prefix per, so it becomes percarbonate. Now we're going to subtract an oxygen down below, CO2 2-. Again, the charge stays the same at 2-, but it has 1 less oxygen. So that's 1 less oxygen than 8. You call that ite. It's carbonite, carbonite. Next one, we're going to take away another oxygen, so we're just at CO. We have CO1, in other words. It's still a 2- charge. So that's 2 less oxygen than 8, and that's called hypocarbonite. So you memorize the 8, in this case carbonate. 1 more oxygen is percarbonate, 1 less is carbonite, and 2 less is hypo. Hypo means below carbonite. The charge on the ions does not change, only the number of oxygen atoms. So let's do another one of these. So sulfate, SO4 2-. So you should memorize that one, both the formula and the charge. Memorize the 8 ions. Now we're going to go up above, SO5 2-. That's 1 more oxygen, so that's called persulfate. Put per on the front of it. That's 1 more oxygen than 8. Now we're going to go to 1 less oxygen. That's SO3 2-. That's sulfite. Again, the 8 becomes an ite, and that's one less oxygen than 8. And finally, we're going to take away one more oxygen from that. It's SO2 2-, and that's hyposulfite, and that's 2 less oxygen than 8. And that takes care of naming. Okay, so the assignment is kind of short. You just practice some of those, and go ahead and we'll talk about those next week. All right, have a good weekend. Have a good day.